that if I want to know how high this cliff is, and I know that the ball is at the edge of the cliff in 4 seconds, all I have to do is use the two-dimensional motion, or the position function for y. Does that make sense? Because the position function with respect to time, right, is that x equals x0 plus v0 t plus 1 half at. I can say y is equal, and then we're saying y0, we're starting at 0. So y0 goes away. And I can say, I don't know, something like vyt plus 1 half at squared. And a couple of things, vy, of course, I should have cracked this vector right away. And I get vy is equal to v sine theta. So then, and we know that a is equal to negative 10 meters per second squared. So I get y is equal to 30 times the sine of 60, 0.866, so it's going to be like 26 or something, times time, which is 4, so 26 makes 104. So this becomes 104 minus 5, oh, just kidding, yeah, whatever, 5t squared. So it's like 104 minus 16, 5 is 80, so this becomes 24 meters. We continue y max. So this one, the way I'm going to do this, what I'm going to do is it's max altitude when what happens? Yeah, when Vy final is 0, right? Throw anything up, stops before it comes back down. So when Vy final is 0, we know that Vy initial is V sine theta, which we know to be, what did I say, 26 earlier? And we know the acceleration is negative 10 meters per second squared. So what do I use? I'm going to use Vy final squared equals Vy initial squared plus 2ax, or ay, as the case may be. So y is going to be V final squared minus Vy initial squared all over 2a. So this becomes 26 squared, which, I don't know, almost 700 or something. And then divided by negative 20, what is it? 6, okay, almost, okay, so negative 676 divided by negative 20, which gives me 33.8 meters, or 34 meters. Yeah. I'm sorry? I don't know. What was the initial velocity? It was 30, right? And I think that was times sine of 60, which I believe is 0.866. So 0.8 would be 24, and then 0.06 would be 0.02, whatever, or 0.018. So I don't know, whatever. It's rounding off, but I think it's around 26. Yeah, it's 25.9. Oh, okay, there you go. Close enough for government work. Okay, questions? Okay, now we can say a couple things. Vf, the V final, right, is going to be equal to a Vy final squared plus Vx. Now, why didn't I put a Vx final? So how do I find this Vy final? Just, like I said, don't get confused by multiple dimensions. Just ask yourself, how do I find the final velocity of an object that's under acceleration given an initial velocity? There you go, right? So we say V final of the y, or Vy final, is going to equal to Vy0 plus at. Okay, and we know Vy0 to be V sine theta plus at. So then I believe we said this was 26 minus, what was the time, 4 seconds? Yeah. Okay, minus 40 gives us negative 14 meters per second. And that should make sense. Okay, so then this is 225, and that's 196. So that's 421, 400, it's around 20, right? Is that right? 20 squared? It's around 20. This is 14 squared plus um, plus 15 squared. What is it? 30? I don't know because I'm not doing it. So it's 14 squared plus 15 squared. It's what? Oh, cool. Per second. So theta is going to be the inverse tangent of v final of y over vx. Vx. Why am I doing that? YouTube, not YouTube, on GrooTube or whatever, somebody on Facebook found this thing, this video from that Despicable Me movie. And there's this guy who says, did anybody see that? No? Okay, one person. Two people. Do you know who Vector was? And did you? Because he says I'm Vector. Oh yeah, it's recording this.